Hello, AP Environmental Science. It's me, Miss Willis, and I'm here to talk to you about nuclear energy today, which is a key fundamental concept in our energy unit, which is Unit 6. All right, so let's go ahead and get started. The way that nuclear energy is generated is through this very important element named uranium, and it's specifically an isotope of uranium, which is uranium-235. So what we have figured out, what we do is we take this uranium-235 molecule and we split it. And that process is called nuclear fission. And as it splits apart, this atom releases a tremendous amount of energy. So we try to harness that energy and use it to generate electricity. Now, because uranium is an element and it's mined, it's considered a non-renewable resource. And also, in order to make sure that we can use it properly at a nuclear power plant or a nuclear facility, we mine it and put it into these little rods that are called fuel rods. So when you see a fuel rod at a nuclear power plant and you hear about it, just know that that's uranium that is used to be split. Who has the most uranium? Well, yes, it is Australia, followed by Africa, North America, Europe, South America, and Asia has the least amount of uranium. So these are the areas that we look to when we need some uranium for nuclear energy. Like I was just saying, in order to harness the energy that is released from uranium, we have to obviously apply some sort of threshold or stimulus. And when we do that, uranium will split into different pieces. Obviously, it will release energy in that process. Some of the other things that are released, though, are fission products and neutrons. Now, what's important is the neutrons that are released will go hit neighboring uranium atoms that are in those fuel rods, and it will cause those uranium atoms to split as well. So they're used as more of like a chain reaction, like a domino. So once they get released from just one uranium molecule, they go and they hit a neighboring one, and it causes that uranium to split as well. So you do get huge releases of energy in a relatively short amount of time. So remember when we were talking about how you generate electricity from coal and natural gas? The same basic fundamentals are used here. So you take your uranium-235 and you process it, you enrich it a little, you add some oxygen, and you turn it into this nice little fuel rod. And then you take these fuel rods and you lower them into what's called heavy water. Now, this heavy water is special because it has an excess amount of neutrons. And remember, you need neutrons in order to be able to split that uranium. The fuel rods go in there, the chain reaction begins, the uranium starts to split up, and as it does, it releases heat. And then what do we do with that heat? Well, of course, we take it and we use it to turn water into steam. And once you can turn that water into steam, we can use it to spin a turbine to create or generate electricity. So it's the same idea as in coal power plants, same idea as in natural gas power. You just want the water to be able to turn to steam so that you can spin a turbine and generate electricity. All of these reactions take place in what's called the nuclear core. So you have your fuel rods, but then you also have these other things called control rods or containment rods. And their whole purpose, like the name says, is to contain the reaction. So sometimes this uranium can really start breaking down and decomposing. So you need to be able to absorb that heat or absorb the neutrons that are causing the chain reaction to slow that reaction down. So what you can do in the core is to drop these containment rods in near the fuel rods so that they absorb those neutrons so that those neutrons can't go to neighboring uranium atoms and cause them to split. Just like in any energy resource, there are advantages and disadvantages to using that energy resource. One of the good things about nuclear power is that in the grand scheme of things, it does have a low rate of accidents or deaths when you compare it to things like coal mining and coal transportation or oil spills or oil accidents like in Deepwater Horizon. So overall, if you're talking about safety, nuclear power actually has a low rate of accidents and deaths. Another good thing about nuclear power is that the nuclear power plants really don't take up a lot of land to operate. So you have very little habitat loss with the operation of the power plant. This is not including the mining process because obviously you know uranium mining can be very destructive on the environment. We're talking about just the power plant here. So very little habitat loss in the creation and production of the power plant. When nuclear power is produced, there's not very many air pollutants that are released from the power plant. So you won't see nitrous oxides or sulfur oxides being released from a nuclear power plant. This is different when we talk about coal and natural gas. There are definite air pollutants that are released when you burn those materials. One of the not so good things about nuclear power is the waste that's created. And so fuel rods, they typically last for about 2 to 5 years. And after that, you have to store them in safe areas. Now, that uranium that's left over, it has a very long half-life. What is a half-life? It is the time for half of that material to degrade. So if you start with 100 grams of uranium-235, it takes approximately 700 million years for that uranium-235 to degrade to 50 grams. And then it takes another 700 million years to get to 25 grams and another 700 million years to get to 12.5 grams. So you see, we are creating this waste that's going to be around on Earth for a long period of time. And the question is, well, what do we do with it? Now, there are two different types of waste that are produced from nuclear energy. We have the high-level waste and the low-level waste. Now, high-level wastes are extremely radioactive. They're still really toxic, so we have to store them in some safe place. Usually, it's required that they're in some sort of encasement or storage container, and they're kept away from, obviously, the public. Low-level wastes are nuclear waste products that you see oftentimes used in medical facilities and so forth, and sometimes they have been put just in steel drums and dumped in the ocean. But they do still have to be specifically stored, but they're not releasing as much radiation as, say, a fuel rod that you would get in a nuclear power plant. A fuel rod would definitely be a high-level waste because it's releasing a lot of radioactive activity still. Nuclear power plants, they tend to be found near waterways, and that's because these power plants, they draw water from natural resources, cold water, and they use that to cool down their machinery. Now, what they do after they use it is they put it back in that same waterway. However, the temperature may not be the same, and this is what we call thermal pollution. And yes, it's actually a pollutant. You're changing the temperature of the water. So they're sucking in cold water, releasing hot water, and that hot water has been shown to hold less oxygen. Animals tend to hover over the heated water, and that could cause, obviously, reproductive problems or migration problems. And even sucking in the water that's cold, you can definitely remove larvae and things like that from the water. So there are issues with this thermal pollution that's being created from nuclear power plants. What you're seeing here are fish larvae, and fish larvae, they're baby fish, if you want to think about them that way. When nuclear power plants do suck in that cold water from their water source or waterway, those suction pipes can actually kill larvae that are in the water. So they get sucked in and obviously become deceased in the operation of the plant. Even though in the long run, nuclear power has been deemed to be one of the safest energy resources, that doesn't take away from some of the deadly nuclear accidents that we've seen in the past from nuclear power plants. One of the very famous ones that you should probably know and remember is the one that happened in Chernobyl in 1986. This happened in what was then known as USSR, but now it's in Ukraine. What happened was the cooling system that was meant to keep the core cool, it failed. And so that led to the melting of the uranium core and caused a huge explosion in the core of the facility. Approximately 4,000 people died and many, many more got sick and were damaged, radiation poisoning from this deadly accident. Here's a picture of what Chernobyl looked like after the accident. So you can see there was definitely a large explosion that occurred at the core. I love this picture because it's been deemed as the elephant's foot. So this is a picture of the melted uranium core that existed at the power plant. And then, of course, if you want to see how deadly this was and how far-reaching the radioactive cloud was, you can see in day 2, there's a picture on the top left there. So you can see the radioactive cloud wasn't so big, but then as the accident progressed and more radioactivity leaked into the atmosphere, it spread all over Europe. So what does radiation do to you? Well, it actually can do a number of things. Definitely eye damage and cataracts can be created from increased levels of radioactivity. We have developmental problems, especially if a woman is pregnant with a fetus. Damage to bone marrow, brain damage. You can get tumors, rashes, all sorts of things were seen, unfortunately, in the people of Chernobyl after the accident. A second example of a nuclear power accident just recently happened, and it was in Japan, and it was called the Fukushima nuclear disaster. And what caused this unfortunate accident is a natural disaster, a tsunami. So a tsunami was created from an earthquake that was deep in the ocean, and the tsunami took out the nuclear power plant that was on the coast. So from that, we had nuclear leakage into the water, and there was a massive cleanup effort for this power plant. And lastly, there was an accident here on our own soil. It was the 3 Mile Island nuclear reactor accident in Pennsylvania. And there was a minor meltdown that happened at this site in March of 1979. Now, lucky for us, not many people were injured. But after this, pretty much we have not created any new nuclear power plants because of the occurrences of accidents. So where do we put this waste, right? We have all this nuclear waste that's being generated from these power plants, and we really don't know where to put it for 700 billion years at least. So here's some of the possible plans. Some people have advocated for putting a storage center in Yucca Mountain in Nevada, which is out in the middle of the desert. So burying it under in the ground in encasements so that no one can have access to it. We could potentially shoot it into space or bury it under ice sheets. We could bury it under the mud in the oceans or break it down, but that would be extremely energy intensive. All of these have advantages and disadvantages to the proposal, to the plan, but I think the answer is clear. There's not one real answer to how we are going to dispose of this. And we end with a map. So this is a map of places where nuclear waste is currently being stored. So we have different levels. Remember, there's the high level and the low level. So depending upon what kind of waste it is, that will determine the location. And then I like this map because you can see where the possible structure of Yucca Mountain is. It's at the south part of Nevada, just north of Las Vegas. So it's a possible site. It continues to be debated to this day. And that concludes our talk on nuclear energy. So I hope everything was great. See you guys soon.